Good morning. This lesson is from our trig pre-calc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. And our goal is to learn how to write the domain and range for graphs that are not bounded in both directions. And this is a really fancy way to say how to explain the domain and or the range for graphs that go forever left and right and or forever vertically. I think I just did a TikTok. Alright, so far we can write the domain, which is our x description, which is horizontal, and our range, which is our y description, which is vertical, using the following two options. Okay, so if my graph is left of something or below something, then I'm just going to use a single inequality. For my domain, and if my graph is right of something or above something, I'm just going to use a single inequality. Right, I'm going to use x. Above, I'm going to use y. Right, but I can describe some situations using one inequality. The second way that we know how to talk about domain and range is when the domain and range is bounded, meaning that there's a beginning and an end. Right. So here, if I have a left point, or a point that's the furthest left, and a point that's the furthest right, horizontally, I bound it. Same for vertically. If there's a lowest point and a highest point, again, I bound it. So that we have two ways that we can write the domain and range. And so what I want to do is I want to use what we already know how to do to answer this question. All right. So first of all, I have this graph right here. And I kind of left a clue on the board. What bounds this graph in this direction? So maybe let that think and let that kind of move around the back of your mind as I move forward with this example. Okay, so up to now, we would talk about the domain and the range in the following way. The domain, which is a horizontal description, we could say that the graph is right of or at -3, right? Now I want to make this more mathematical. I would say x is right of or at -3, and this is how I would mathematically explain that my graph is right of or at -3. Range, I would say that my graph is above or at -2. And so, again, I'm going to use these single inequality symbols to explain my graph. So, mathematically, it's going to look like this. Y is above or at vertically. Our graph is above or at -2. So this is what we know how to do. But there's another way that we can explain this domain and range. Okay, so we've done it using this method. We can actually do it using this method. And it goes back to that original equation. What bounds in that direction, and what bounds in this direction, right? Because our graph goes forever to the right. Our graph also goes forever vertically. So we can describe the domain and range using our bounded notation. Okay, so let's try that with the bounded. Well, I know that my horizontally for the domain, I know that we're going to be between, for sure, my furthest left value is -3. But how far right does my graph go? It goes infinitely right. So we're going to say that our graph is between -3 and infinity. All right. Now, I have to be very careful which one of these I use. All right. So I know that I have to use a closed symbol because I'm at -3. But can I ever get to infinity? Is that an open circle idea or a closed circle idea? And it's an open circle because you never can get there, right? So I can use this to say that my graph is between, horizontally, -3, because we're at -3, and we never get to infinity. But this would be how I discuss this domain using the bounded notation. All right. Range. Well, my graph is the lowest point is -2, so we know that we're between -2, because that's the lowest point. But my graph keeps going up forever, and so vertically our graph goes to infinity. So we know that we're between -2 and infinity. So I have a lowest point, my -2, and I have a highest value, my infinity. But again, I can't get there, so I have to use this inequality symbol. So my range could be written like this. And that would be a way that I can explain this domain and range using the bounded notation. And this is a clue on how I'm going to write the domain and range for graphs that are not bounded in both directions. So hopefully you kind of figured out how this last problem is going to go. All right. So let's write this using bounded. Okay, write the domain and range using a bounded form. Alright, so the domain. What's the farthest left my graph goes? How far left does this thing go? In fact, it goes so far left, we can say it goes infinitely left in the negative direction. So the domain is going to be between negative infinity, because it goes forever left, and positive infinity, because it goes forever right. And so using my bounded notation, I can say that the domain is negative infinity less than x less than infinity. And I just described a graph that is not bounded in both directions. This means that it goes forever in both directions. Now the range there is an obvious lower bound. There is a lowest point, and that lowest point is -3. So I know that my graph vertically is between -3, but it rises forever to infinity. Okay, so even though it's going in both directions, it's still rising up to infinity. I feel like I'm tick-tocking again. So I want to use my bounded notation, and it's going to become -3 less than or equal, because it is at that point. Use my y less than positive infinity. Okay, so this is saying that I start at 3 and go up forever. Start at -3 and go up forever. Okay. So again, I'm hoping that you understand how I can write a domain and a range that is not for graphs that are not bounded in both directions. So what I did here for the domain, you could see graphs that go like this. And you would have to make that for the range. It goes down to negative infinity, it goes up to positive infinity, so you would have this version down here. Alright, so hopefully you understand how I tied this idea together with this idea, allowing me to answer the question, how to write the domain for an unbounded domain and range. So I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a great day. Bye-bye.